Hello, I'm going to, in this video, go over one of the questions from Chapter 4, Section 4. This is exercise number 152 from Chapter 4. So if you haven't looked at this question yet, I suggest you pause the video and kind of read through the introduction of this scenario. Okay, so we're looking at difference between proportions of schizophrenics who own cats as children and the proportion of control group. People do not have schizophrenia who own cats as children. And they want to know if the proportion of schizophrenics of children is larger. Is there a larger proportion of the schizophrenics who own children than the control group? So the first thing I want to do is write down the hypotheses. So I don't require it in this question, but I want to kind of go through how I would write a hypothesis, null, and alternative. So the first thing you want to do is write down the population parameters. We have two different proportions here. So I wrote them as P subscript S and P subscript C for the proportion of schizophrenics who own cats and the proportion of the control group who own cats as children. And the null hypothesis would be that the proportions are equal to each other. The alternative in this case is that the proportion of the schizophrenic group would be larger than the control group proportion. And note we could write the hypothesis two different ways. So you don't need to write it both ways, but I like kind of showing both different ways of writing these hypotheses. We could subtract the P subscript C to write the null and alternative hypothesis as a difference as opposed to setting them equal to each other. So these would be the hypothesis, the sample statistic for this, and I'm just going to focus on this video on the 1982 data, the difference between these two proportions, P hat S minus P hat C, and these two numbers come from this first row of data, 1982. Subtract those two proportions to get about 0.0798. Okay, so I want to figure out the p-value. And so we're going to need to go to StatKey to get the p-value. So I need to keep these numbers in mind. I'm going to go to StatKey, and we're doing a test for a difference in proportions. First thing I'm going to do is edit the data. I'm going to put in the 1075 over 2125. That would be the schizophrenic group. Then the control group is 2065 over 4847. Click OK. And notice the sample statistics right down here. Rounded to 3 decimals, you get 0.080. And to get the p-value, I need to generate some samples, create a randomization distribution. I'm going to do, let's see, 3,000. To do at least 2,000, I'm going to kind of go through StatKey. And since our alternative hypothesis is a greater than, this is going to be a right tail test. Click on right tail. And notice a lot of confusion in this section comes from thinking the p-values, 0.025. But to get the p-value, we need to change the statistic. So down here, kind of the StatKey randomly makes this about a 0.025 pretty much every time. So to get the p-value, we need to change this bottom entry to our statistic, which is 0.08. So 0.08 is 8% difference between the two groups, not a 2.6% difference. So before I click on here, notice this statistic is going to be much further along down the line. And the p-value is the proportion of these, red dots, the proportion of samples that are as extreme as the value or worse. So if I click that and change this to 0.08, because that's our sample statistic, click OK. Notice I get a lot farther away from the center. The null is 0 because we assume there is no difference. And p-value is statistically 0. It's not exactly 0, but it's pretty close to 0. And this is how you get p-value. So make sure to change this bottom entry, and that will get the p-value for your hypothesis test.